right, so hello everybody, I'm Dave Matthews, and this is the first episode of the FailKast. And with me, I have a very esteemed co-host,
No,
Stefan Weiss.
very esteemed.
Stefan, who are you? Why are you here?
You know, I'm just an old tech nerd like you, Dave. More software than hardware. You're definitely more the hardware guy. I've been writing code since I was 8, and from there went to Microsoft and built a bunch of products that you probably dislike. I apologize for SharePoint just out of the gate. I'll just say it honestly. And some that you probably really liked. So I've been writing and building software for as long as I can remember, and then left that and did some e-commerce stuff and sold that. And now I'm fully into more e-commerce stuff, investing and all that kind of jazz. But really what I care about is just technology and making our lives better through tech. I had a blog once, Better Living Through Copper. I think it was a blog, or maybe, and the idea was just literally a copper wire that came into your house before fiber was the way to actually, enhance the quality of your life. But yeah, that's who I am.
A very good one. Dave Matthews, is he alluded, I am a hardware guy. I'm known on the interwebs as the gadget guy. I've hosted a few hundred TV shows talking about gadgets and technology, and have been behind some fabulous flameouts like the QCat, which was the first IoT device, a barcode scanner that could scan any product in your living room, your kitchen, and take you to the exact website for that product. And even a product that won an Emmy, the Slingbox. I was on the team that made the TI DSP that would compress video and send it anywhere in the world, way before streaming and YouTube and all the takedown notices from copyright equipment.
Yeah.
So we thought we would talk about.
All right,
So we wanted to talk about the FailKast, to talk about things that we adored, that we missed, or things that companies got really, really wrong. And we thought we would kick off the first inaugural episode with the death of Intel Corporation.
Oh, man, probably a little overstated, Dave, a little hyperbolic. I don't think it's going anywhere necessarily. It's not dying, but certainly it's could call it Walking Dead, like a zombie. Would that be cool?
And I like that. And Intel was hampered by legacy upgrades, let's call it. So as they went from higher speed memory, the memory would go very fast, but the bus would go very slow.
The South Bridge.
Yeah, the North Bridge, the South Bridge. Why did we need two of them, by the way? Was that another legacy thing?
I don't remember. I know the North Bridge was designed to be basically your RAM, right? And that was closest to the processor. South Bridge was everything else. So your PCI buses, your USB, every other
Graphic
IO went through South Bridge. Yeah, I'm sure there was a good reason. Here's the reality. I'm not a chip designer. I'm sure there was good reasons for it. I just don't know what they are. And it kind of hampered the performance of those Intels for a generation of machines, a few generations of machines.
Mm-hmm. And we're stating the death of this because Apple last week announced their new processor, the M1, which was based upon developments from a company they bought in 2008, and that was Palo Alto Semiconductor. And they're one of these companies that's called a fabless sim. So it's a bunch of guys with software that make no silicon wafer, right? So these guys just have amazing code that will design the layers of the CPU, which is the transistors. And they don't have to have any expensive manufacturing. So Apple actually used Samsung for the first phones, the smartphones. And I have the second Apple iPhone here. They didn't call it the iPhone 2. They called it the iPhone 3G. And that was more of a marketing play because
it had 3G.
Yeah, it had the 3G phone. So the first iPhone was a 2G device. This one, look how curvy it is here.
Was that just fully edge? Was that all it could do? I don't remember. The first
one did, yeah. The first one did.
Edge, right? Yeah, this is. Here I have the newest one, which is beautiful and blue and extraordinarily fast.
And that uses the A14 processor from Apple, right?
That is correct. That is yes, A14.
And the A14, again, that's the lessons that were learned that went into this M1 processor from the team at Palo Alto Semiconductor. And I'm sure Apple purchased a dozen other companies.
Absolutely.
Secret sauce.
Yeah, and I'm sure, and they have a bunch of in-house chip designers as well now too. They've really hired over the years people who understand silicon. But what really got them to this point was a big bet on the ARM that was part of iPhone for the last 10 plus years. You saw it coming, right? Because all the iPads that were dropping in the last couple of years, they would almost always benchmark them against PCs. So even though it's not a fair comparison, but they would always show you the numbers. You know, this is the gaming performance, this is the FPU performance, and then this is versus a PC. So you always saw this coming, but it is clearly a big swing to migrate an entire ecosystem, if you will, in this case, the Mac, you know, to an entirely different chipset architecture. And maybe people are asking, why is that a big deal? And Dave, as a hardware guy, you can explain probably, and I'll do the software side, like why it was such a big deal to move from Intel to an ARM processor.
Yeah, so let's back up a little bit. So there's x86 architecture, which is what Intel did, and that started with 4 megahertz machines, the 8086. So that's why you see the X.86. And those machines were the original IBM PC, and eventually the clones like the Compacts of the world. And that x86 architecture just kept getting faster and faster and faster. And it got more and more cores. And it was limited by how many nanometers those transistors could be placed next to one another.
Right.
And the ARM architecture has some more efficient capabilities. It can handle multiple cores more effectively. And you'll see in this latest M1 processor from Apple, it's got up to 8 cores of CPU, and half of those are high speed, half of those are low speed. So now we can handle the low power capabilities there.
Which is brilliant.
Right? So think about that. You can, and Cadillac did this with the North Star engine with vehicles. They had a V8.
That's right. They knocked down the 4 cylinders when you're in efficiency mode. Yeah. Right. See, so Cadillac was always ahead of the curve. I knew it.
Yeah, if you think about what if you don't need all 8 cylinders to run, why are you putting all the gas in those cylinders, right? So it's the same thing with the cores of the processor for this M1 from Apple. And the other thing that they did that was clever was they have just as many cores for graphics. And if you think about what Intel was trying to do with their chipsets is get the graphic engine as close to the processor as possible. Well, with ARM, Apple was just able to make this 5 nanometer engine with the graphics and the CPU all together and the memory on the same bus. And I'll pop up a picture here for those of you that are watching. And this this memory is just a little bit faster than what your DDR3 would be. It's not monumentally fast.
Not crazy, no.
But the fact that it's on the same die, which is the same silicon substrate, and it's not even made by Apple. This is SK Hynix RAM, which Apple's been using as a vendor for many, many years now. This graphic processor and the CPU inside the ARM processor can both talk to the memory without redundant caching. And that is why I was hyperbolic with saying Intel is dead, because they put everything together on the same die. So now the pathways don't have to go through legacy 400 megahertz buses in some cases to do this interchange.
Yeah, I think the one thing I would say that makes me a little tweaked out is everything, all the RAM is shared, right? So on a stock M1, a stock MacBook Air or Pro, and really the only ones you can get right now are the 8 gig models. You are actually everything, including the graphics memory, everything is competing for that same pool of RAM. Now it can page to the hard drive as it will do, and because everything is so close and right there, paging should be a lot faster than we've seen in the past. There's no spinning plates, there is no bus has to go through. It's all just directly to that flash drive. But still, you know, if you think about it, a lot of these memory like graphics cards you could buy for PCs and whatnot themselves had 8 gigs of RAM just for the memory, just the cards alone. And so the fact that we now have to share, frankly, the constrained resource, which is the RAM, among all the systems, all the parts of the system, it's a little bit concerning. And I'm actually beginning to see it now on this MacBook Pro with 8 gigs. There is some stuttering that's happening more than it was.
So let's talk about the use, because you've been using yours for a week now.
I have.
And the advertisement, which I loved during the keynote of debuting this One More Thing, which was the video, you can go look up and see this. It showed an Apple executive
doing this. I'll do it. It's like you can't see it because obviously.
Oh, look at that!
It was Craig, and it was a yellow. It was almost like Barry White's "Sexy Time." To be clear, that's what it was.
It reminded me of a little bit of 2001: Space Odyssey when he was looking into the eye of Hal.
Mm-hmm.
So as he
Yeah.
opened it, I think that that video was to show that as soon as you lift the lid, it's up and ready to go. But look,
Oh yeah.
Stefan, my MacBook's done a decent job of doing that already.
Yeah, I agree. I agree. I think the whole wake on, or the wake on lid open was a parlor trick, because to your point, my Intel based Mac did the same thing. Maybe it was a half a second delay, but never more than. Now when you open the lid, it's already on, which is magical, but like nothing's going to change my life there, frankly.
But Big Sur, which is the operating system, the most recent version of the Mac OS, which is the multitasking version as well. So we should state
True.
that the iPad uses a quasi multitasking
Yeah.
operating system, meaning
Tombstone's apps basically in the background.
that's right, puts
Yes.
them in the
Suspended
storage.
animation. Yeah.
Yep. So Mac OS is a true multitasking operating system. I mean, you can have 50, 60. I read some reports of the M1 having hundreds of tabs open in Chrome,
True.
and it still is able to come to life quickly. Now, there's two versions of hibernation for Macs. There's write to RAM and write to flash. And I think what they're saying there is even written to flash, the flash performance is 5x of
So
what
fast.
normal flash would be because of the removal of these legacy Southbridge
Buses.
architectures, right?
Yeah. And it is smoking fast. It is smoking fast.
So talk about normally Zoom brings a fan on in a machine. And,
yeah, let me just check really quickly here. I don't think I'm pretty sure. Hold on. No, it's still off. It's still off. I mean, here's the reality. There's one big gain that this thing has. It's not this, everything is the same. The webcam's the same, the keyboard's the same. They fixed it, thank God. Everything's the same. The device is the same. What really matters to me, and even the speed, frankly, like maybe it's a little bit faster here and there, but I'm not. That wasn't ever a massive problem with the initial Intel Macs, even, right? What you're getting in this thing is thermal performance. Doesn't get hot anymore, which is lovely. So you're sitting here working away. Your palms aren't sweating.
Yeah.
Unless you're doing something you shouldn't be. And then the other thing is that battery life is just is bonkers. I mean, that's really what it comes down to. So, you know, I'm sure a lot of us now are on Zooms or Google Hangouts, or pick one of your 1,800 different platforms of video conferencing now. And you know very well, an hour Zoom call, an hour Hangout, whatever it might be, an hour Teams is atrociously bad for battery. It just will take down your battery by 30-40%. And if it's an older battery, even more than that. And I've now with the M1 and the Pro, I think an hour call might take 9% if I'm really unlucky, maybe 11% top end. So very, very, very just sips, and no fan, to Dave's point. It's so good that it doesn't even make this system hot enough to spin up a fan, which is amazing.
And I can talk a little bit about why Zoom crushes CPUs, because this is what we did with the Slingbox. We were compressing video, and we used a special chip from Texas Instrument called a DSP, a digital signal processor. And DSPs are unlike normal CPUs like x86 and ARM CPUs in that they're designed to do a single task.
One thing, yeah.
One thing, right? And that is to compress video. And there's different codecs out there. There's H.264, which is MPEG-4, and that's what a lot of like the videos that you download onto your iPhone would be, or even your Apple TV uses a lot of that. And then there's a new codec, H.265, and you'll find video conferencing is generally using those newer codecs. And they require the CPU to do a lot of math, a lot of number crunching to take the pixels that are moving as I wiggle my head, and turn those into frames that can go across the internet. And the higher the compression, the more CPU power. And what's nice is the less bandwidth that's required to get that video over the link. So the reason why the fan boots up when you're in a Zoom is it's compressing packets to encode and send them over a wireless link. And wireless links, if you're on a modern Wi-Fi system now, those are fast. And if you have fiber, even better. But your CPU still has to do the heavy lifting of this.
Yeah, so there's a few things, right? So it's the initial compression of the picture we're seeing 30 times a second, right? We're moving, like as my hands move, it's got to figure out what it can leave alone. Like this back here is this background here isn't moving, so it can kind of just leave that alone. But the second I do this, now it's got to actually, oh God, it's got to do something with that. And so there's a lot of math that it has to do to figure out which pixels among this massive screen around me need to change, which ones can stay the same and not. And that's a lot of computation to do that 30 times a second. And that's where we get a lot of the CPU burn. That's why Zoom, and not just Zoom, anyone that uses any compression algorithm is going to be shitty. And so, Dave, why don't we just broadcast? Why do we even bother compressing?
Well, because some of us still go through legacy systems like cable or something that might not be as fast as a fiber link. And not only that, is all the peers in between where you're going on the internet. If you go on a mobile phone connection, generally in cities, those are connected by fiber. So the radio link is very fast and the fiber link is very fast. But you can be out in a rural area and you'll have your wireless connection maybe going through microwave hops or wireless hops from tower to tower. And each one of those, it doesn't exactly half the bandwidth, but you're now sharing with everyone else on the towers in between. So microwave links are really the limitation you have now with mobile devices. But you're in Mexico. We have a low latency connection here.
It's pretty good.
We're on
it's pretty good.
Tethered connections. And I'm at the escape cabin in the Ozarks. And,
you and I are quarantining properly. Yes, exactly. Yes. Yeah, I've actually had to have the guys who own the property install new links for me here, because when I got here initially, it was pretty pokey. I'm not gonna lie to you. There were some sketchy video calls I had to have where I had to explain to people that I was not gonna be able to do video because there's a little pokey. Hey, we're solved now. Technology is a magical thing. But Dave, I feel like we're getting away from the FailKast, and I think everyone should know that the reason we're doing FailKast, the reason I want to do the FailKast, Dave wanted to do FailKast, was because there's no end of people saying how awesome they are and what they and things that have worked for them and how you should replicate that. And I mean, I have a lot of friends, right, that do that. And I think it's great. But to me, like, the things that have really taught me the most are not when they have gone well, because at that point you're simply exercising confirmation bias and saying, yeah, I'm so good it went well. Obviously, that's why I went well. I'm so good. The reality is, I think I've learned more from things that totally blew up, and I think the feedback there is a gift, right? When something doesn't work. So that's the point of FailKast, is to highlight creators and people who've had things go totally pear-shaped. Not to have Schadenfreude or gloat, because although I'm sure I'll do that occasionally. More just because I think the lessons you learn in failure are A, funnier in most cases, and B, more poignant than those that you learn by crushing it every single time you try something.
And the favorite quote that I have for this is, "Success has many parents and failure is an orphan."
Yeah, it's never my fault. It's my fault mostly. So yeah, so back to Intel. So has Intel failed? I mean, it's tough to call Intel a failure. Actually, in no sense could you call Intel a failure, right? They pioneered the personal computing industry, and in every way they made the world a better place.
And Gordon Moore, one of the inventors, created the term Moore's Law, which is playing into their failure, I would say.
That's right. And so Intel was really good at, almost like Apple did, frankly, and the whole tick-tock. They released, they have the same die size or the same nanometer fab process, but they would incrementally every year kind of update, that core architecture, from Skylake to, I forget all the code names. It's been too long, but all these really cool, sexy sounding code names. But at the end of the day, they were incremental improvements. Like, I can't think of the last time Intel. It had to have been maybe 2011 when they introduced Northbridge Southbridge. That was like a massive architectural change. I mean, they had the M processors for low power and the ULVs for low power, but all these things were kind of
Celeron for the low cost.
Oh my God, this is Celeron. Oh.
But my favorite is when they started adding the multimedia extensions, MMX,
MMX.
back in 90. What was
that? That was the Pentium. That was the Pentiums. Yeah.
Little bits of libraries that would be able to make media better. And this goes back to the days when CD-ROMs had video on them instead of audio CDs, which were generally...
Seventh Guest, baby. Seventh Guest. The best game ever.
That was a game where you would go through a virtual digital environment, and not too dissimilar to, remember, Dragon's Lair, which was Laserdisc.
Laserdisc in the arcades.
In the arcades, that's right.
Oh my God, it's such a good game. I never got past the fourth screen. I was the worst at that game, but
yeah. So these games use the Intel extensions to be able to quickly decode the video portions of the media, And now there's so many extensions on modern CPUs that it's hard to keep track of. But Apple has this neural engine, and to me, that neural engine's, a bit hocus pocus. It's an ML, a machine learning layer, and what is it, 16 cores in this?
16. And they kept talking about how all these machine learning tasks on MacBook Airs are going to be so much better. I'm like, show me a rack of MacBook Airs running ML models. I'll show you a startup that has too much money. But anyway.
Yeah, and I'm using a MacBook Pro here. You're using a MacBook Pro. Mine has a 720p camera. Yours has a 720p camera. But I can't help but notice that your complexion, although you being slightly younger than me, I can't help but notice that your complexion is amazing. What's going on there?
Well, part of it is massive surgery. No, you're seeing with the exact same webcam, to your point, same hardware in this device, but they are using their ML, or they're doing something. Who the hell knows what it is exactly? Same thing they're doing with the iPhone, frankly, to enhance the appearance of those on cameras. If I could shut off the ML right now, I would look like a Skeksis from the Dark Crystal. It's that bad. Yeah. So thank God Apple has. That's a deep cut for those of you, the nerds out there. Hopefully you can go look at that. What was it? The Geldot? What was it? The Geldings and the Skeksis.
Yeah, that's yeah. We'll
Jen was
in the comments, but
yeah, because the reality is now I look like the Gelding, but without the ML, I'm like a Skeksis. Yeah, but that's right. They're basically doing tricks rather than improving the hardware. They're using software to improve it. So back to Mark's notion that software eats the world. You're seeing it happen right now.
Yep. And I'm not seeing effects like what they call the bokeh effect, which adds a level of distortion or blur behind you. And that's what they're doing on the iPhone. Even the 12, which has 3 fabulous cameras in the Pro model, they're able to do some depth of field tricks through lens.
Yeah.
And then they add a software layer on top of that with the iPhone. And I'm not seeing as crazy.
I don't think, I mean, there might be, I don't think there's any, I know if you, no.
No controls yet.
Part of it's, yeah, I don't think they've made that accessible to third-party apps. I know in FaceTime, for example, in the new version of FaceTime and Big Sur, and with this, it might just be Big Sur actually. Maybe it's only on the M1, but they now do eye gaze correction, which is totally creepy.
Oh yeah.
So they launched that.
So the camera is mounted at the top of this
here.
Up here.
All right.
And
but I'm looking at Dave right here.
Yep. So they literally perform digital cosmetic surgery
in real time.
In real time.
Yeah.
And is that happening now on this device?
No, because it's in Zoom, so it only works in FaceTime. So what'll happen only in FaceTime. So they haven't made that available to third parties yet. So what's interesting, I tried it yesterday. It's kind of no, that's on my iPhone. Hold on, I'm not sure it works in the Mac yet.
Yeah, I don't think it's doing it. I know it works on the iPhone.
Oh, I'm sorry. You're right. I'm thinking the iPhone. Never mind. I'm wrong.
Talk about the process for this.
Yeah, it is creepy. So the same problem here on your iPhone. You've got all the you're looking down here on the screen versus up at the camera. And so what they've done now, as you're talking to someone, that they literally identify, probably using, I'm assuming some of the Face ID tech in this thing as well. They identify the ocular openings here of your eyes, and rather than as you're looking down, they remap it. They just they move the eyes and pupils up to appear as though you're looking directly into the camera. Which
this is going to don't shoot until you see the white of their eyes. It's the digital version of that.
It does, I will say, look, it's a little unnerving, because we're also used now to kind of looking off kilter and these things. And now when you're talking to someone on FaceTime, you're just like, why are you looking at me like that? Like, why are you staring at me? Like, what's going on? So but yeah, I'm assuming they'll add it into this too. I'm not sure why they wouldn't add it into the Mac as well at some point, but you're right. I think it should be iOS.
They've got the cores for it, so why not?
They've got the cores. The cores. Yeah. So I think that's the big challenge for Intel. I think is just that the tick-tock, the slow and steady, partially to deal with just backwards compatibility. That's part of it. That's where Apple, I think, this is a big swing, right? Moving to your own silicon, big swing. Moving to your own silicon, which is a fundamentally different architecture, which means all the legacy apps that have been written for an Intel processor and architecture, in theory, shouldn't work anymore.
Right.
That's a big swing. And so
they did this 3 times. First, they started with the Motorola 68000.
Yep.
And they went to PowerPC, which was a joint development with
that was IBM. A RISC-based proc, right?
Yep. And they had their Finally, the Intel
Mm-hmm.
version. So they were able to, they didn't have levels of Rosetta that they needed back from 68,000 to G5. I think apps just didn't work anymore.
This didn't work.
Yeah,
Yeah,
you had to
this
get new
didn't work.
apps. But when Apple went from the PowerPC architecture to the Intel powered CPUs, they created Rosetta. And Rosetta was some middleware, some code that would run within the operating system when needed. And it
Yep.
would convert the code from the old G5, which was their top end CPU back in the IBM partnership days, to Intel. And now they have something called Rosetta 2, which I love the Rosetta Stone, by the way. It
It's
was
such a great, yeah, it's such a great name.
a great
It's perfect.
analogy. They were able
It's
to use
perfect.
the three versions of different Egyptian language and hieroglyphics to decode hieroglyphics through finding of this Rosetta Stone, which had
Yeah,
three exact copies of the same script.
Such a great, I mean, as usual, such a great code name from Apple.
Mm-hmm. So Rosetta 2, which blew my mind, has greater efficiency at running on this new ARM architecture, x86 code, than running it natively on x86. And we haven't seen this before. Normally, when you run
You
an
always have
interpreter,
overhead, right? Exactly.
yeah, interpreters have overhead and it runs slower. And this, you can play with interpreters going back to like MAME, which is the
Oh
multi-machine
yeah.
arcade.
Wow.
And you can take old video games that would run on your Atari console and play them on your PC. And your PC's 1,000 or 2,000
That's
times
not,
faster.
you don't notice the difference there. Yeah, exactly.
Right. But generally, you would have an architecture conversion overhead, and we're just not seeing that there.
No, so you be careful. So I was reading a blog last night, as one does when you're trying to fall asleep and you're a nerd. I can't remember what it was, but there's a guy on the web who has issued a very strongly worded letter to Apple because he is seeing some issues with Rosetta 2. I have not seen him yet. He's claiming that OneNote's sluggish. Haven't seen that yet. Outlook crashes. That's just Outlook. So I haven't seen that yet.
Feature.
So yeah, that's just a feature. No, it's actually quite good. But he's now compiled an entire list. A lot of Adobe apps don't work. And there are things like Google File Stream doesn't work on my machine here, so I can't actually stream files from my Google Drive, which is a pain in the ass. So there are a few things that we are seeing that aren't working. I'm not sure if that's a Rosetta problem or just actually a Google File Stream app problem. But my point is, he's now making it a mission, kind of like Casey Neistat did with the Apple iPhone battery back in the day. He's trying to get Apple to put an asterisk on their marketing materials to say, because it says basically runs just like normal. And there are probably 15 or 20 apps that are encountering some kind of either degradation or non-function period. So I haven't seen a lot of it yet.
But because this is such a radically new bus, I would say that a file system, because you're running on a SSD drive as before, but now the input output through that SSD is different.
I think it's that. I think this is just the Google file streams rather than, so when you it's like Dropbox. When you want a file, it streams it down from Google Drive to your machine, and it's just more. I think they didn't update the code or something.
But the Chrome team, talk about that.
Chrome, wow, that was fun.
Chrome was there, and then it went away, and then it came back, and now it's two binaries.
So Chrome, when I got the M1 last, whatever it was Monday, I guess it was, or Tuesday, Monday, whatever day it was. It's all the days blur together. Who knows what day it is anymore? I just know at some point I can have Thanksgiving. When I opened the machine, I was getting it all ported over from my Intel, which is a flawless transfer. Then I went to install Chrome, and it popped up, hey, do you want the Intel or the M1? I'm like, oh my God, they already have an AMD 64 version out, right? Or ARM, whatever it was. They actually call it funny. This is a funny story. So back in the days of Microsoft, you would have apps that would be on 64-bit apps or 32-bit apps, right? And so when you would go from the internal file trees, you'd install these apps, you'd have, I think it's just called Win32 and ARM 64, right? For some reason, they put the ARM in front of that. And that's how you knew it was a 64-bit app. Well, sure enough, on Chrome, when you went to install it, it actually said AMD 64 version, which I thought was on a package name. So it was such a funny thing to see that. I'm like, why would you call it AMD 64? But they didn't. Anyway, point is, Chrome launched a native 64-bit M1 or ARM native chip, and ARM native Chrome app. They pulled it down that night after I got it. I don't know. There's some bug apparently which is causing massive problems, and then put it back up. So for like a few hours, I was probably one of a handful of people on the planet.
People were
had
freaking
Chrome
out.
build. Yeah, it was amazing. It was amazing. But now everyone's got it. But it's a Chrome was and continues to build. Chrome was, at least on the Intel boxes, a massive memory hog, a massive performance hog. If you open more than 10 tabs, it was like, forget it. You'll see the beach ball from now until next Thanksgiving, if we make it as far as a species. But now with the new ARM 60, AMD 64 build, it actually, I hear no more fans. I haven't had the challenges we've had before with Chrome. Battery life is pretty good. Hangouts works better than it does in Safari. So, good for them. They took advantage of it.
And Apple talked about this in Safari, being able to, if you're like me and you have a bunch of tabs left open and you like to go on airplanes and read through stories and delete tabs. And maybe it's not airplanes anymore, but maybe it's F-150 truck drives to 8 hours and you want to read stuff. The ability to kind of entomb those tabs and make them fall asleep in the background is something that
super nice.
It's nice to have, right? And just delete the tabs or cut and paste the content if you're a researcher. That's a clever application. But I really haven't seen it's been promised, but it hasn't really worked well in actuality. Are you saying with this new M1 architecture and the Chrome tabs are able to go to sleep? Or do you think that this processor is just so futuristic with its 8 cores of high speed and 4 cores of being able to flip between the 4 and 4?
4 and 4, yeah. No, I mean, at least according to Google, they are actually putting tabs to sleep now. So when they're not being active foreground, they are no longer. I think the old days, the problem with Chrome is it would just continually, kind of spin, even if the tabs weren't foreground. So I think they actually are doing what they said they're going to do, which is super helpful.
I want to give a quote from Steve Jobs about being insanely great. And the keynote to announce this M1 processor was just called One More Thing, which was typically what Jobs would do at the end of the keynote. After he blew your mind with whatever you were saying, he'd be like, oh, you know what? There's one more thing. So I was looking at some of quotes that Steve Jobs put out before this podcast here to figure out which one really mapped to what they wanted to do. Because I would say that Apple was always in control of the hardware and software, but they had vendors building the chips inside. So this is the processor that Apple really wanted to build. And I like this one. A really great person will keep on going and find the key underlying principle of the problem and come up with a beautiful, elegant solution that works. So this is a beautiful, elegant solution. They take all the lessons that they learned from the iOS device and fast memory and bus and new architecture like ARM, and insanely greatly stuck it all together as to something that just works.
That is elegant and true and beautiful.
Now, Steve Jobs also talked about the perfect television, which I don't think we've quite seen yet. And the Apple TV was a clever box. One of the companies I helped with, Boxy, we actually took those first Apple TVs that had hard drives in them and modified them to play a special social media player. Samsung bought that company and brought it internally, and for a year they worked on it until they failed it. So maybe we'll talk about the Apple TV in a future episode and what they figured out that was innovative that Jobs would tease the press about.
I would love to actually talk about Samsung generally. I think that one is, to me, a company that has purchased so many products and has butchered them. Most of them from my friends. I don't want to name names right now. I just want to make sure they're okay with me talking about it. But they have truly purchased so many products and done such a poor job integrating them. I can't even think of one they've done that's been good.
Well, we'll save that for another episode.
That could be a fun FailKast. Yeah, I can think of 2 right now. That 3 actually I can think of right now that are just disasters. So.
All right. Well, I'm Dave Matthews. I'm the gadget guy, and I like to talk about technology and how it makes your life better. And with me,
as always, is Stephen White. I'm not the gadget guy. I'm just a sometimes embittered old tech nerd. But hey, that's fun too.
Well, thanks for watching the inaugural Failcast, and we look forward to seeing you again on a future episode where we'll talk about how we got to where we are today and
Ooh.
why we want to be here or not.
Bye, buddy. All right, hold on. Hold that thought. I have to the bathroom because I drank too much water. Hold on. We'll edit this part out.
I hope you just peed off the balcony.
I totally should have. No, I did not. No, I actually went to the proper toilet.